Hello, Dr. Mike here. This is for my Cybersecurity version 2 playlist, and this is on Topic 10, which is on baseline and secure software development. This is in accordance with Chapter 11 of the same name. And we're going to look at the chapter, and I'm going to bring in some stuff that is outside the chapter that I think is important we look at when it comes to this topic. So I'm not going to read the chapter to you, but the chapter is basically broken down into two parts. First part really is about baselines and baselining. So we talk about system hardening, which is a very, very critical. I mean, when it comes to any kind of server administration, and not just server administration too, switches, network, everything, any kind of anything that's attached to the network, even laptops should be hardened. Things that get carried in the field. So this process of hardening really applies to all aspects of IT and with security. So again, first part, to talk about that, and really it's pretty much straightforward stuff that seems to make sense, right? Disable unnecessary services, permissions on files and directories, removing unnecessary software, applying patches. That's a huge deal. Of course, we know patching is a big deal. Unnecessary users. Using password guidelines. So we talked about, if we haven't, we talked about usually be some sort of a security policy in place. So we have an administrative policy saying passwords must be XYZ, changed every X days, and or have a multi-factor authentication token. Now we actually put a technical aspect into play to enforce those. And we'll see a lot of times that's used with PAM modules, the auth modules for the PAM for Linux, and of course we have Active Directory policies that we can use for that. So guidelines for that, in case you see Windows here. So hardening Windows, I'm not going to go into each OS. We got to think from the boot on, so it's possible even on the boot, from the bootloader on too. Don't just think about the OS, think about the entire system itself. So the chapter goes over some topics here to look at. Data execution prevention, it's a real good one to look at. Different services that aren't needed, disable unnecessary services. Also, this goes along lines with our talk about encryption and services, our previous topic, I believe, which of course is use secure services. So think about how we emit stuff from that system and how we bring traffic in. Do we need to have Telnet running? If we do, then why? And if we have to, for some reason, and it's, you always think, well, don't use Telnet. Well, yeah, definitely don't use it if possible, but there's some legacy system in place, some app, something that needs to have it, and so you have to figure out a way to harden that, mitigate any chance for that. Maybe could we have a special account that's isolated for just for Telnet only? So you have to be able to sort of have a contingency for less secure services. So keep that in mind. Linux, same thing here. It goes into that, hardening managed user accounts, hardening accounts. One of the biggest, of course, things with any OS is the administrative password or admin accounts or root. There's some simple things, of course, firewall configuration and things about Mac. So something that I've seen before, for example, with Linux, is our SSH service. Make sure you have SSH. And in our sshd.conf file, here's an example here. In this file from a Linux box, there is a setting to allow root. And I'm not remember the exact, to allow root, yes or no. You set that from yes, set that to no, right? And that means root cannot SSH in. So there's no root SSH. And you think, well, how's that work? How, if sysadmin needs to come in and support the system, how they work? Well, they SSH in as a regular user ID with its own strong password, maybe MFA. And then in the system itself, either use something like sudo, or they'll have an SU, whatever. They'll switch user to root. Probably use sudo, but then they might need to switch user to root. So SU to root, and then of course have another, and this is a very, very strong password hopefully for root itself. So you add an extra step, but that means is you avoid attacks, people coming in and trying to brute force, or even guess, or even if they know the root password, they can't come in remotely. They got to be as a regular user ID. So that's an example I've seen. I've set up myself for Linux systems for hardening your system out. So we'll look along here. So I'm not talking about the different OS systems themselves. Firewalls, yes, definitely want endpoint firewalls on both as much as possible. Something else you can do is TCP wrappers on Linux. And that is as the host.allow, host.deny. You actually can limit what services you have. So for example, let's talk about SSH again. So SSHD does fall under TCP wrap. It has a wrap lib library as part of that binary. What it does is in the host.allow, I can say SSHD is only allowed from a certain network. I don't know, 121.1.0/24, let's say. So what that means is my firewall has to allow port 22 in for SSH. But what I can do here, though, is with the wrappers is say, well, yeah, you're allowed to come in. However, unless you're coming in from a certain subnet, maybe within the company, I'm not going to allow you access. So you limit who can access that service. And there are certain services that allow this. Not everything does. There's a check you need to do. Look for librap.so. So look at the LDD command, LDD, which is your library. See what the binary for SSH, your daemon library is compiled with. So, and if you get you look at host.allow, host.deny, or TCP wrappers, it'll guide you through all the stuff. The Red Hat docs have all that information, and the old CentOS docs, things like that. But again, you work in conjunction with firewalls, and it really does harden SSH, for example, or FTP, this is say, or secure FTP. You can do the same thing. Maybe we only allow a certain internal subnet, so we only allow from a certain range of IP addresses, or even a single IP address, or one or two IP addresses. We know that SFTP is used for backups, and so our backup server, we have two of them running on two IPs, or a really small subnet, and that way no one can come in remotely and try to hack SFTP. So along the same lines, these have their own users. Those user accounts are constricted. And another thing too is something to look at is called SE Linux, Security Enhanced Linux. And that goes along the lines of authentication and authorization. It's more of an authorization thing, and I think I talked about that in the auth video, so I won't go into that here. So there's a lot of components to this. Big one, of course, updates. I mean, patching and hotfixes. We definitely know that. So again, there's tons of guides out there. System hardening for your specific operating system. If you're running a Red Hat OS, Red Hat has documents and guidelines. Microsoft's got tons of those. I'm not going to bring them up here. But also, look, you have NIST guidelines too. So, and this is the NIST 800-123 SP, special publication. And you use this as it's only 53 pages, and like a bulk of those are the introduction and stuff, so the background. But you can get into planning, and this might help you plan out your baseline image. Now, I'm talking about baselining. The chapter talked about this in the beginning. You build what's called a baseline image. So whether it be Linux or Microsoft, you test whether the apps it has to run. So make sure it doesn't, of course, it works. With the web server, it can run your web server, all your web server frameworks, things like that. It can run proper load testing, all those aspects, but security is definitely part of that. And you have that image done, and when you create a new server, you use that image. It's called provisioning, usually, and you provision the image out. So this planning is really important. Have this planning in place. And then here you see patching, upgrading, and so on, configuring OS. So this is a small checklist of things to look for. So fantastic document. Use this as a launching point to create your own maybe server policy, for maybe like a Linux server policy, a Windows server policy, that might get really more into details about things that apply to your business and what protections it needs and what it needs to make sure it runs successfully. So this is a great way you can describe this document, use it again as that stepping stone. And probably one of the biggest things too, which is another topic we're not going to talk about here, is backups. Backups are huge. So I mean, a backup system and a logging system. So backup for the data. And if you have a proper provisioning system with patching, you don't really need to back up the OS. What you want to have is your OS image, and then you probably have either a partition for your database, if there's some sort of database. And it could be a database, it could be your worldwide www content, your web content, whatever it may be. It could be home for users, maybe it's development content, for users to log in and compile code, share code. It could be content used for maybe a Python server for data analysis, with connection with the DB. So whatever it is, you want to keep this separate from the OS. And what you do is you back up this stuff. Definitely have backups. Have multiple backups of this. Weekly fulls, nightly incrementals, things like that. And then the OS you have from your provision image. And what you do is, if something happens, you don't reinstall the OS, anything like that. You definitely will do is you'll partition a new system, and of course you'll reapply a copy of the image back to the OS, and you restore the backups for wherever it may be, and you're up and running. So a big part of the backup plan is also recovery. You can take all the backups you want in the world, but unless you can test and prove they work, you don't want to find out the day you need to have a backup that your last week of incremental backups have been corrupt because of a bug, or the past month of the data is bad. So a new way to verify these backups and show their integrity and have a process, a plan in place, and to test recovery of an entire server, of a chunk of data, a database, things like that. So this actually goes into a different topic later in the course here, which I'm not getting into. So I'll stop it here. We're looking at this at business continuity. So we'll talk more about it there, but you can see where backup is a huge part of this. And a part of your patching plan, a big part of your patching plan, of course, is if you need to patch production. So what you do is you usually have your image, your master image. It's an M. Your master image, and you have a test environment, and of course you have production. So what you do is, before you patch production, you'll have a copy of production typically, which is the same as your image. You'll patch it here first. Apply your patches, run your tests. If they're good, have a plan to apply those patches to both production and to patch your image. And have a backup of the previous image, and of course have a backup plan in production in case we need to roll back. No matter how much testing you do, something's always going to happen. Something's missed, and then the Friday night, the Sunday, they roll us in production, and they go, wait a minute, this is broken the database. We missed something in testing. Have a way to back it out and recover and continue on. So a big part of this is change management. There's a lot of parts to this here. So change management is huge. Again, and we're going to look into the territory of this topic here. So I'll leave it at that. But understand that it is part of your server policy and baselining. So, and one of the last things to talk about here before we move on to the second part, which is application hardening. And this sort of lies within both. We have our OS, and then we have our app code, right? Whether that be, HTML5 development, database, Java, whatever our app stack is here, and our OS here. We have the odd man in between here. Just our framework. So things like Java struts. So Java struts, for example, or JavaScript frameworks, Node.js. These frameworks are weird. Our apps are going to rely upon them, and we'll probably have them as part of our OS. It could be part of our image. It might not be. This is a questionable thing. Usually you keep it along the app side of the house, but everyone's different. But know that this is definitely a weak point. So there's actually a great article here. It's linked from this OWASP dependency checker. So yes, OWASP. Talk about OWASP again. Before we dive into application hardening, we're going to bring up OWASP. OWASP has a tool called Dependency Checker. When you either do a Maven or a Gradle or a Homebrew, whatever, how you ever do your Jenkins, for example, I've seen it used for Jenkins systems. When you have your system that compiles your code, all your developers put it into your Git repository. Jenkins pulls out the current release and compiles it. And a big part, of course, is look for compilation errors, issues like that. But during that, these plugins will say, hey, since we're going to compile the code for your app, what version of this stuff are we currently using? And it'll go out and it'll check and say, are there any vulnerabilities for these versions? If there are, I'm gonna flag a report on the compile time. This is a huge thing that gets missed a lot. And there's a link here. Unfortunately, all the insecure libraries. And here's an example for CVE-1870, struts framework. This stuff sounds familiar. The huge hack that happened with the there you go, struts. Yeah, there you go. So I mean, there's stuff here. Struts, an old framework, 5 years old, has been hacked before, and it's been part of huge hacks in the past. So Equifax. Equifax came through a old struts framework, which they were warned about, but they never patched. So this is sort of a black hole that gets missed because it falls in between. Is it an infrastructure component, server, or is it an app component? Wherever it is, find ways to make sure you are checking these. And this is one of many. This is a free one. Use something. But yeah, during your compile time, have this thing out and check and tell you, hey, by the way, you're using an out-of-date struts framework. It has these vulnerabilities. And of course, you don't have to patch it right away. Just knowing that is important. Then you can evaluate it. Well, does this vulnerability actually apply to us? Maybe it doesn't. Maybe the conditions of the vulnerability don't apply because you're not using that certain code base or that certain condition. Because when you patch these, you do need, of course, you got to test your app out. So whenever you change frameworks, you got to test your app. And so it does take time, but knowledge is key here. And again, this ties back to OWASP Top 10, which we're going to bring up again here, number 9. Using components with known vulnerabilities. So libraries, frameworks, other software modules. So this ties back to that. So anyways, so this leads us into the next part of this, which is application hardening. So again, patch management still applies though. So we look at patching software. We also, in patching our operating system, we should also look at make sure we patch any software that needs to be patched. It could be endpoint software. It could be stuff we use for processing data, log analysis, data analysis. Definitely want to have this in place. So there are security templates you can use for group policies and templates. So of course, Active Directory has a lot of stuff for this. VPNs, make sure all the software examples patch for that. We've seen VPN hacks here lately in the news. But really, we're looking at secure development lifecycle. So this is an important thing here. We move away from patching, we move away from stuff. We're talking about just writing the code. I'm going to reflect back here again to our OWASP Top 10. Injection, broken authentication, broken access controls, misconfigurations, still one of the big ones here. You got to be able to bake in security early. in the software development lifecycle. So what is software development lifecycle? There's several kinds of these. I'm not going to get into all of them. You have all kinds of different types of development life cycles. Typically, though, there's some sort of requirements. Then you go to development, and you go to test, and from there, you'll find stuff that will need to be changed and rolls back into a new requirement. And you begin this sort of spiral until you get to the point where you get to a version 1 of your software. There's all kinds of these. Waterfall is the old one. There's more agile processes in place where you break this into smaller chunks. And I'm not getting into all the aspects there. But this one, the biggest thing is if you can bake in your stuff early in design, start thinking about threat modeling early, the easier it is to code for it. So it's going to be cheaper to design it here than to go back and patch it here. So our version 1 of the software is out. We find out there's a security vulnerability. It's going to cost way more money and time, which when I say money, time and money go hand in hand here, to change our version 1 versus spend a little extra time and money designing and testing as part of our security. So software development lifecycle, and unfortunately, testing gets hit. When it comes to software development, release date is key. And there's either customers who want the software a certain time, just time to market. A lot of factors press software to get out the door early, and we see the problems with bugs. And patches, we'll patch it later, right? In some cases, you can patch minor issues later, but a missed security issue can be really bad, especially day 1 out the door. So this goes in and talks about design phase, things you can do, decomposing assets, classifying threats, and so on. It's good to have a security person as part of the software development early. Again, because testing, they get the pinch. I say testing, I don't mean software I don't mean security testing, I mean software testing. So, not unit testing, but maybe unit testing, functional testing, integrated testing. There's so much tight schedule for them that security usually loses out, as well as testing also. But there's things you want to look for, and it sounds fun, but buffer overflows, using secure libraries, injection. So have this stuff in early in design as much as possible. So this talks about it here, the testing phase. Different types of testing. Fuzzing is very important. This can actually roll into your regression testing. So if the testing team uses some sort of regression tools, a lot of times they'll automate testing. So they'll go into the app and they'll fill out the form automatically, and it'll hit next and get the expected response. And there's tools to do this. Years ago, I did this in software testing called Rational Software. It was pretty cool. Use visual VBA scripting to sort of read software forms. There's all kinds of stuff to do for web-based also. And this is a great place you can say, can we interject some fuzz testing, which means go into the form. So for last name, our last name form, put in numbers. Once I put numbers inside there, once I've put in, how big can it be? Is it only supposed to be, the last name is supposed to be the largest database, maybe, is 64 characters. Once I put 64,000 characters in the field, the database only holds so much. The stuff in between, the logic in between. What if I put in, a huge chunk of numbers or characters? Or what if I put in hex code, or I put in a SQL injection? SQL injection, dashes. I put in, some basic SQL injection code. If you can automate that within your regression testing, and then come back and say, yeah, there's an issue here. As soon as we put in, anything over 128 characters, we get an error. So that's good. Thing is, what kind of error are we seeing? Error output. Error. That error output's important. As a pen tester, I will try to press the system out and get an error. And the error output, if it's not properly formatted. If it just dumps me to an error, it gives me a database error, for example, I know for sure that's bad. I'm actually in the database directly. That means I can maybe try some SQL injection. Maybe the error is from the app framework. It might expose some framework information. So you want to make sure you have custom error pages. It's sort of one of those error pages you see that say like, hey, system ran into a problem. Please contact our help desk at this number. You don't want a dump to straight error page. So error pages, and this is called fuzzing a lot of times. It's a great way to go ahead and if you can get this in, look for buffer overflows, look for potentially just all kinds of stuff. You can automate this. It's fantastic. So if your testing team has automated testing in place, see about leveraging them to do fuzzing. And the last part here, of course, again, and this I've mentioned this before. Top 10, the OWASP Top 10 is fantastic. This is, a great way to say, how can I talk to my development team? You'd be surprised. Like, I don't know what an injection. Talk about what does an injection mean? Literally, you can copy and paste this stuff into an email and put the links. So here's where I got it from. This is what it is. Here's how we can prevent it. Here's some cheat sheets we can use. Here's an example. You got to be able to talk to the non-security minded folks. Explain this to a manager why they need to spend an extra 3 days of development time, which is money, to go back and fix this. Now, hopefully, security is up front now. But you start mentioning, we're going to be an injection could give us a possible data breach. That might get some alarm bells, even to the non-tech person. So luckily right now it's in the news a lot. No one wants to be in the news for the latest data breach, so this might bring some light to that. But you can give them some more detailed explanations, and this is fantastic utility for this. I can't say enough about OWASP. So again, understand testing. That old testing, white box, gray box, black box. How does testing work? This white box and black box is really more software testing, but also applies to pen testing or penetration testing. Part of your final testing, of course, should be of all your systems. Should look at a vulnerability scan and possibly a pen test. Now, these both overlap. But a vulnerability scan is fantastic. Run this stuff, run Nmap scans against your network, run a vulnerability scanner against all your systems, against the test system, at least, or in the test environment. A lot of times you run this type of scanning in production, it could impact production, so you might get pushback from any kind of DevOps. But if you have before they disassemble, take down a testing environment, after a full-on test is done, say I need to run a vulnerability scan. Schedule a scan for that night, let it run, and get the information out. Pen testing is vulnerability scanning with more though. It could be internal. You have a team. This is going to look for all kinds of stuff that any vulnerability scanner is going to miss. Process controls. Is there a way I can hack the help desk? There are things that were missed. Password reset procedures. That's always a good one. I look for password reset forms and pages. So we'll leave it with vulnerability testing and pen testing. You definitely want to be able to find time and budget, both for either done internally or externally. Again, not all teams have even the tools for vulnerability scanning. Maybe you can get a contractor to vulnerability scan your test environment and do a pen test against your production environment. I know people are like, don't want to test production. There's really no replacement for testing against your production environment, especially a pen test. Even early on aspects, which is a lot of reconnaissance. You can test all you want in testing. The real life stuff, though, you can't beat hiring someone to look at and say, what happened if someone tried to hack me right now? So, other ways to look at things like HackerOne. You can do bug bounty programs. Try to leverage someone to say, hey, we'll put a reward out, $500 if you can find and prove there's one of these OWASP top 10s in our system, or $1,000. And the idea of paying someone you didn't hire as an employee seems first seem crazy, but it's fantastic because have $1,000, put $5,000 away, keep it as payment to HackerOne, for example, for a bug bounty. You want to leverage community as possible. Otherwise, people might turn and just sell your stuff on the dark web. So try to turn that to good, for example. So leave it at that. That's the last part of the chapter, and that wraps up this topic on baseline and secure software development. Thank you.